Now let's move on to chapter 25, which is reflection of light. And we talk about mirrors. There are so many ray diagrams and figures, which all you have to read yourself, and I'll show you. I have enlarged those pictures here. There are hardly 3 or 4 worked out example, maybe 5 total. So that also I mentioned to you guys in this lecture, so you can read those. So let's start with the first one. How the light or the wavelength wise, they're all different. So this is a spherical surface like a ball globe, and these are the wave fronts as you see, and the rays are going in the direction where marked red. Okay, so this is a typical spherical view of how the sound wave is transmitted in this sphere. If they were wavelength, then again we call them as wave front. The distance between two wave fronts is the wavelength lambda. Okay, and the ray is perpendicular to the wave front at the point of the direction of velocity of that wave. Now comes the real reflection. Look at this. A ray is coming, which is incident ray. Then it is reflected back from the surface, which is a mirror here, or any reflecting surface is still good. And we draw a normal to that meeting point where the both rays meet, incident and the reflected ray. The angle between the normal, like theta I and theta R, has to be equal. That's the law of reflection. Here is a plane mirror. A guy is standing in front of the mirror, and there are 3 things you will observe. The image is upright, and the height of the image is same as the height of the object or the person, and it is exactly behind the mirror, the same distance the person is standing in front of the mirror. So the guy standing in front of the mirror, we call it object distance. I mean the distance from mirror to this person standing there is object distance, and the image you see inside is the image which is the same object distance wise. Yeah. Now we are in a different figure where eye contact for the object and how you see the image. There is all lined out as incident angle theta 1, reflected angle theta 2, or theta I, theta R. So this figure shows you the geometry used in plane mirror, how the image distance and the object's distance is calculated or located. And you have the angle also shown here, alpha, theta, beta, and all that stuff you can name it, but they are equal here, as you see, theta equal. Now this is your object distance, this is image distance. It's exactly the same as you see in this figure you have. There are actually two types of mirror. From a sphere we cut a slice. Okay. The inner surface will be concave, the outer surface will be used as a mirror, will be convex or diverging, but better word is convex mirror. So we have concave mirror and convex mirror. So this is showing you right here is the reflecting surface is inside. And I will again show you, I believe you see that, but there is a marked down alphabet as C, which is the center of the curvature. This whole circle is like this is the radius of that circle, which is known as radius of curvature. This is a better picture to show you. Look, here R is marked as the radius of curvature, as I told you. F is the focal length or focal point, marked F. So F, which is the focal length, is half of the radius of curvature. The radius of curvature is this, then half of that will be F. This one shows you geometry again. We need 3 different rays to draw the picture, so we can calculate the image distance depending on where you put the image, object distance, and the location. Everything you can do by taking ray 1, 2, 3. So you can read out ray 1, 2, 3, one running parallel, otherwise going to the focal point. All that stuff is just self-explained, nothing to worry about, no equation involved at all. This figure is more clear with the eye, how the image is formed and how the rays are crossing one point. So you know the height of the image from the drawing. See, so far we have been only using the drawing part, whether it's a real image or a virtual image, to figure out looking at the mirror. But eventually you will see we'll use 2 simple equations to calculate either of object height given the image height related to the focal point. So that's all 3 about the concave mirror. The one I'm showing you is convex now. Look at this. The reflecting surface is bulging outside, and this surface is not reflecting. Okay, and the arrangement of rays are same. You have to take 3 rays to figure out from the geometry the image height. the object is at a certain distance and I is on this side. It is again the convex mirror. As you see, it's bulging out this side. And now it's important topic here, which is known as mirror equation. F is the focal length, as I said. D0 is the object distance. Then di is the image distance. We want to find out the magnification of the mirror. This is a better picture to understand. Here you have all the symbols: D0, H1, H0, focal length, all that is here. So there are two parts, A and B. You can look at those diagrams. It's easy to understand. Now this is my final page. There is no more topic included in this chapter, which is 25, reflection of light. Okay, we went through the figure number in page 710. Look at this: H0 divided by negative Hi equals D0 over Di, due to the similar triangle which you can see in this. I'm going to back to the previous page. See, similar triangle here, similar triangle here, similar triangle here, similar triangle here. These two. Okay. Now repeat again. H0 over negative Hi equals D0 over Di. And again, you're rewriting, you get another equation is the same: H0 over Hi negative equals D0 minus F divided by Di, and Di replaced by F. So finally the mirror equation comes to be 1 over D0 plus 1 over Di equals 1 over F. That is the mirror equation, which is very important to solve problems. Magnification equation: M is the magnification, which is Hi over H0, image height divided by object height, equals negative Di, image distance divided by object distance. You can go over the example 4 on page 711. Now comes, how about the convex mirror? The convex mirror is the next example, which is example 5 in page 712. This explains how you put a negative sign to get back to using the same equation. So you have universal sort of mirror equation and magnification. These two are the only two equations which are involved in solving all the problems you have in this chapter. That will be the end. I'm going to go to 25 maybe tomorrow or day after. Then that will be I'm talking about 25 is done. I'm talking about 26 or 27. Either of that I'm going to go for. Okay, thank you very much.